Once again, taking a look at that penny lab, our very last reaction that we did was one where we had this blue solution that we knew was copper 2 plus, and we added solid zinc to it. And what happened was that that blue solution became colorless, and the metal that we saw at the bottom started turning this rusty brown color, and that was due to obviously the copper metal. Zinc started out as a shiny silver, and so we could see that the zinc metal disappear and the copper metal come into play. If I take a look at the potential for this reaction, it is 1.10 volts. So the question is, how do I get that value? Where do I get it from? Again, if I take a look at Appendix L in the back of the book, where all these potential values are given, these tables are usually set up as what are called reduction potentials. And so what I can find in that table is copper 2 plus 2 electrons, giving me copper metal, and the potential for that is a positive 0.34 volts. Again, this is a reduction half reaction, and when I look in table Appendix L, I also see zinc 2 plus 2 electrons, giving me zinc metal. This is a negative 0.76 volts. Again, this is a reduction half reaction, and we cannot have two reduction reactions happening simultaneously. We can have one reduction, and if we have that, we must have an oxidation half reaction to go with it. So I'm going to rewrite that second equation to read zinc going to zinc 2 plus 2 electrons. And if I turn that equation around, I also have to flip the sign of the 0.76, so it's now a positive 0.76 volts. And so it's this reaction and this reaction which are being added together here. And so I end up with copper 2 plus zinc plus 2 electrons. I'm not going to write those because they cancel out with the electrons on the products, but I get copper metal and zinc 2 plus. And now I can simply add those two potentials together, and that's where I'm getting the 1.10 volts from. All right. These voltages for these half reactions are all relative to another reaction, and that other reaction that they are relative to is the reaction of H plus 2 electrons going to H2, which I had already mentioned has a potential of 0 volts. I cannot measure just a half reaction, because if I have a reduction half reaction, I have to have an oxidation half reaction. So we had to arbitrarily set some species up to be our zero, our standard. And so this week in lab, we're going to be looking at determining what the potentials of some of these half reactions are. And so if I had a number line, right, and let's say I had 0 volts here, right, this would be due to the, let me take that out, this is going to be due to the H plus and H2, we call that a couple. So that's 0 volts. And then out here we would see another measurement at 0.34 volts, and that's going to be due to the copper 2 plus copper couple. And then on the other side, way out here, we're at negative 0.76 volts, and that's going to be due to the zinc 2 plus zinc couple. And so the difference from here all the way over to here is going to be a difference of 1.10 volts. And so if I know what one of the potentials is, and I can measure something against the other one, then I can find out where that potential is on my number line.